Ladies and gentlemen, good afternoon. I would like to thank you for giving me the chance to report my research here. Well, today I will present my paper, An Improved DDoS Attack Detection Model Based on Unsupervised Learning in Smart Grid. Next, I will introduce my paper from four aspects: background, research content, experimental results, and summary. As the most widely distributed and complex power IoT system, smart grid has involved many aspects of human life. So, we can say the smart grid system is actively shaping the world of industrial production and consumption, and its characteristics can be summarized as involved in a wide range, complex structure, many types of equipment, and so on. The right chart presents the development trend of market size of the global smart grids from 2018 to 2027. So, while the smart grid brings convenience to humans' daily life and work, it also raises many safety issues. This page presents some network security cases in field of smart grid and power IoT. Obviously, these incidents have brought a lot of trouble to our lives and work, and also brought a lot of losses to the society. Currently, the main attack in smart grid system is based on its communication network, such as famous DDoS attack, which is not only easy to implement but also has obvious attack effects. When a network attack occurs, the most obvious attack phenomenon is abnormal traffic, such as source port, destination port, transaction protocol, status, duration. For the machines based on statistics, through the statistic analysis of historic traffic data, we present a lower threshold and upper threshold to determine whether the current network is abnormal. The detection model, based on machine learning, is essentially the classification method, which needs a lot of labeled dataset. At present, the most of the existing detection methods still have the characteristic of low detection accuracy and high false positive rate. So, in this paper, we proposed a novel DDoS attack detection method, which uses unlabeled abnormal network traffic data to build the detection model and uses Birch's algorithm to pre-cluster the original abnormal traffic data in a way of unsupervised learning. Then, the resulted class 3 subsets are respectively input into the desired autoencoder for model training. The obtained reconstruction error is used as detection threshold to detect the normal traffic and the attacked traffic. Next is the research content. Our method is an unsupervised learning-based anomaly detection framework and mainly consists of data pre-processing, detection model training, and the detection phase. As we all know, the network traffic data generated in different environments will produce different distribution features. Thus, the inherent change of the features of data will inevitably affect the performance of the detection model. That is, the threshold obtained by using unbalanced network traffic data with complex data patterns and distribution features could affect detection accuracy. Therefore, we use a BERT algorithm to pre-cluster the original dataset. Firstly, the abnormal network traffic dataset needs to be normalized. Then the processed data will be imported into the BERT algorithm to achieve the unsupervised pre-clustering of data. In the phase of model training, the clustering subsets are imported into autoencoder for the model training, and the minimized reconstruction error of the trained data is used as the detection threshold for subsequent anomaly detection. In the detection phase, we import the traffic data into the trained model to get its output. Then, we calculate the reconstruction error between the output and its input. If the reconstruction error is higher than the present detection threshold, the test data is marked as normal traffic data. Otherwise, it is marked as abnormal traffic data. In the data pre-processing stage, we use min-max techniques to normalize the data and transform the raw data linearly, which makes the calculation of distance between features more reasonable. In this page, we use BERT clustering features to summarize a cluster and a cluster feature chains to represent clustered hierarchies. This is some indicators. X-ling is the center of the cluster, and R is the average distance from the cluster center to the cluster member. D is the average distance between the two clusters. Autoencoders is an artificial neural network algorithm. The method proposed in this paper mainly utilizes the autoencoder algorithm to learn the data features of the clustering subsets and reconstruct the input data, and use the processing of encoding and decoding to get minimize the reconstruction error of the input data. As a result, we can distinguish the normal traffic and abnormal traffic by using the obtained reconstruction error and the detection threshold. The basic principle of our approach is that data which is similar to trained data will be relatively reconstructed well and therefore has a low reconstruction error. In the detection phase, we import the test data into the trained model to get its output. Then we calculate the reconstruction error between the output and its input based on the mean squaring error function. If the reconstruction error is higher than the present detection threshold, the test data is marked as normal traffic data. Otherwise, it is marked as abnormal traffic data. Next is the experimental results. First we use KDD-COP99 dataset to verify our method and the comparative experiments. In order to get the optimal clustering subsets, we determine the best number of clusters using JPI. The index is also known as classification fitness indicator, which is used to evaluate the matrix of clustering algorithms. This panel presents the structure of autoencoder model and the settings of hybrid parameters used in this method. We use abnormal sample and normal sample to calculate the distribution of reconstruction errors. Through experimental statistics, it can be seen that the reconstruction error of normal traffic data is higher than the present detection threshold, and the reconstruction error of abnormal traffic is lower than the threshold. In our paper, we take accuracy, precision, recall, and F-score as evaluation indicators to verify the overall performance of our model. In order to intuitively evaluate the detection accuracy of the proposed method, we construct the computer matrix, which is built based on the values of TP, Fn, Tn, and Fp. We evaluate the classification effects of the method by ROC curve and AUC indicator. It can be known that the AUC of the proposed method in this paper is to 0.99, which shows that the method has a better classification effect. And we compared the results with the recently machine learning-based DDoS detection method. And all the experimental results show that the detection accuracy of our method is obviously better than that of comparison method. This is because we use BERT cluster algorithm to pre-classify network traffic data with similar distribution features and obtain good clustered subsets. Based on the clustered subsets, we design our static autoencoder to train the detection model, which can learn height measuring features of the pre-clustered subsets and get more suitable detection threshold. Thus, we achieve better detection performance. Summary. In this paper, we proposed an improved DDoS attack detection model based on unsupervised learning, and the experiments based on KDD COP99 dataset show that the proposed method is superior to the comparison method. And in the future, in order to improve the generalization capability of the model, we will consider whether the BERT AE method based on is suitable for DDoS attack detection with various rates in different environments. And in order to enhance the robustness of the model, we consider build a real-time and adaptive attack detection framework to achieve efficient real-time monitoring of DDoS attack in communication network of smart grid. That's all. Thank you. Thanks for your attention.